Dalton's atomic theory. Greek philosopher Democritus, in the year 460 to 370 BC, suggested that matter is composed of extremely small, atomio, mean indivisible particles. The tiny, small, indivisible particles of matter were called atoms. In the year 1808, when different laws of chemical combinations were stated, John Dalton, English school teacher, proposed atomic theory. In his theory, he made following assumptions. 1. All matters are made up of tiny, indestructible, indivisible unit particles, called atoms. Atoms are the smallest particles of the element, and molecules are the smallest particles of a compound. 2. All atoms of the same element have same size, shape, and mass, and all other properties. Atoms of different elements have different properties. 3. Compounds are formed when atoms of different elements combine. The atoms in a compound unite in small whole number ratios, like 1:1, 1:2, 1:3, 2:1, 2:3, etc. 4. A chemical reaction involves only the separation, combination, or rearrangement of integer number of atoms. During chemical reaction, atoms are neither created nor destroyed. With these assumptions, Dalton explained law of conservation of mass. He stated that, during chemical reaction, atoms can rearrange and change their partners. Molecules could be decomposed into atoms. But the total number of atoms in the reactants and products must be same. Hence, mass is conserved during a reaction. Law of multiple proportions was explained by Dalton by assuming that, under some conditions, atoms of two types combine in the ratio 1:1 to form a molecule. Under some different conditions, it may combine in the ratio 1:2, or 1:3, or 2:3, etc. Dalton also proposed some symbols for some common atoms and molecules, shown in the above figure. Oxygen, sulfur, nitrogen, hydrogen, carbon, potassium, water, methane, carbon monoxide, hydrogen peroxide, carbon dioxide. Concepts of elements, atoms and molecules. An element is defined as a substance which cannot be separated into simpler substances by any chemical process. Till today, 118 elements are identified. 92 elements are present in nature, and about 26 elements are synthesized in laboratory. The smallest indivisible particle of an element is called an atom. Every atom of an element has a definite mass of the order of 10⁻⁴ minus 26 kilograms, and has a spherical shape, of radius of the order of 10 raised to minus 15 meters. The smallest atom of the element is that of hydrogen, with mass of 1.667 multiplied by 10 raised to minus 27 kilograms. Atom may or may not have free existence. Atoms of almost all the elements can react with one another to form compounds. The properties of the constituent atoms and the compound formed are completely different. Carbon burns in oxygen and forms carbon dioxide. Carbon is combustible. Oxygen helps combustion, but the product carbon dioxide is used as fire extinguisher. The smallest unit of a compound is called a molecule. A molecule has all the properties of original compound. It cannot be divided into the constituent atoms by simple methods. Under drastic conditions, it can be decomposed into the constituent atoms. Hydrogen gas is inflammable and catches fire in oxygen, which helps combustion. However, the product formed, water, is used to put off fire. Hydrogen and oxygen are elements. Water is a compound. The composition of pure water is same throughout the universe, and is independent of the source place of its resource. In general, a compound is a substance composed of atoms of two or more elements, chemically united in a fixed proportion. A molecule is an aggregate of two or more atoms of definite composition, which are held together by chemical bonds. A molecule may contain atoms of same elements, or different elements.